Berkeley, and then done a year at the Molecular Foundry with Ron Zuckerman. And it was really great to have a chance to connect and have him join the group. And I think what
nerves.
So I think what really defines Stan's time in the lab has been his engagement in so many different activities, both in research and more broadly. So he started on a project that was sort of design and structure in the peptide area that we work in, and published a very nice paper. Along the way, Stan collaborated with many other group members and made himself really invaluable as a member of the team. Participated in just about every sort of teaching role you can imagine for every course, becoming a valued member of the teaching team at UCI. Took a leadership role in safety, both in the group and in the department. I know there are a number of other things Stan calls extracurricular activities that really constitute an integral part of the graduate experience. Partway through his time in the lab, Stan wanted to change directions and do a project that involved expression. Moved into expression of the beta amyloid peptide and published a very nice paper there with a group mate, and now is getting ready to turn out another one. Collectively, what came out of all of this was a fantastic package in terms of a PhD scientist with the sort of hard experimental skills to execute a variety of different projects and a variety of different skills, from synthetic to structural to expression. Also, the collaborative and interpersonal skills to be a great part of a team, and then just a fascination with everything from teaching to mass spectrometry. And so in hindsight, it shouldn't have surprised me that Stan was able to come out of here and really nail a plum industrial position at Roche after, I'm sure what was too long a search for him, but really what wasn't that long a search at all, to nail a very, very nice position and to get to stay in the area he wanted to be in. So I think today we're going to hear about the scientific side of Stan's thesis time and the research time in the department. So.
Right, thank you so much for introduction. I'm not gonna cry, hopefully. We'll try outside now too. So today, thank you all for coming today. I'll tell you today about my experience in genomic lab, mostly focusing on the last 2 years of work in the expression work. So I'll tell you about the amyloid oligomer and A-beta peptide. So first of all, the people who know me, friends, are like, all I talk about is A-beta, A-beta, A-beta. It's all I talk about. So that's gonna be like in this part. So first, let me start the talk by telling you about 3 challenges in the amyloid field. First one is study of amyloid oligomers. Since they are so short-lived, but they're very neurotoxic. Because they're short-lived, it's very difficult to study those oligomers. Their equilibrium is very stable, fibro and the monomers. So I'll tell you a little bit about it. In this project, I'll briefly mention these 2 projects. Secondly, faster production of high quality and high quantity of A-beta peptides are very difficult. In this project, I'll tell you a little bit about how I approach the problem and what's about to get a lot of A-beta. And lastly, I'll tell you a little bit about the site-specific labeling of amyloid beta and how I expressed and came up with a new method for producing class-specific labeled A beta, such as with the dyes. So as I alluded before, A beta is 40 or 42 amino acid long peptide that comes off of this big clip off of this bigger protein called APP, amyloid precursor protein.